Hello and welcome to the SCI-AI podcast. This is episode number 24. Today, I have invited Rudra Sekhri again onto the podcast. This is round number 2 with him. Rudra, as you know, he's a young scientist, 15-year-old, had an amazing podcast last time with him. We had discussed astronomy, astrophysics, and a lot of other stuff last time. Rudra, thank you for coming again onto the podcast.
Oh, it's good to be back, Vivek.
Perfect. Awesome. So let's go ahead and get started. What an amazing stuff you're doing already, Rudra, in your career. You're writing your second book. We are so proud of that. So you can go ahead and talk about it, during this question, as it is on this question. So what is Encaledus, the book that you're writing on, and how does the whole journey to Encaledus looks like? Why Encaledus? Why did you choose to write about it and not other planets or moons in our solar system like Europa, etc.? So where I'm getting onto is, why does Encaledus seems to be more promising for us to settle down, or am I overthinking and you've written it for some other cause? Please go ahead.
Well, I'll first start off by explaining what my book's about. This book is a sci-fi novel, and I've sort of gotten inspiration for this book based on The Martian, which is another really famous book that actually turned into a movie. This book I decided to call Hacking Enceladus, and this book is set on the moon, which orbits around Saturn, and that's called Enceladus. Now, the reason why I chose Enceladus over other planets or other moons is because, firstly, Enceladus is an outspoken an outspoken moon. Nobody really talks about Enceladus, even though it's one of the major contenders for places where life might exist or life may be hosted. Enceladus is actually a ice moon, which means that it's primarily made of ice and maybe a couple of other minerals, which means that it's a great place for humans to set up small colonies, and this small colony can eventually lead humanity to move further outwards into the solar system to Uranus or Neptune, but more importantly, it could be used as a base for potentially interstellar travel. In terms of what the journey to Enceladus might look like, I outlined this in my book as sort of like, a really weird journey in which many things go wrong. And I mean, to be fair, this is a spoiler alert, but the book is primarily about how and why things go wrong, and also just adding a little bit of conspiracy theory. And it's
Right.
pretty wild in terms of what's been included. It also refers back to some of the stuff which has been mentioned all the way back in the 1970s with the introduction of space treaties that prevented the use of weapons in space. And it also goes into depth about what it means. How are you going to enforce law in space when weapons or other forms of, weaponry cannot be used in space to enforce those laws? So, I mean, it's a story that includes various different things, like which is probably what we'll be seeing in the next few decades. We'll be seeing ourselves colonize Mars, colonize potentially Venus as well, terraform Venus, terraform Mars, and then move out further into the solar system. Now, the journey itself is not going to be very similar to the journey in the actual book, because of the fact that while all the technology in the book is feasible, it's all possible, I don't think it will actually happen. I personally think that what will happen is that we'll slowly take over and colonize the outer solar system by first Colonizing Mars, then Europa, and then Enceladus. In this book, I've sort of said that there's a direct flight that goes from Mars to Enceladus, but in reality, it's more going to
Mm.
be a spaceship that travels from Europa to Enceladus. Some of the signs which we might be seeing on Enceladus would probably be looking at and understanding the geography of Enceladus, how it is affected by tidal effects from Saturn,
Mm.
and if life exists on Enceladus, because we have not sent any probes or any rovers or any sort of scientific equipment to be able to analyze that question. The closest we've ever gotten to Enceladus was with the Cassini spacecraft over the past few decades, and even then we've only been able to gather pictures and maybe a couple of samples of the water which was spewing out of Enceladus. We don't actually know if there's a possibility of life arising on Enceladus. But yeah, that's pretty much all that I have to say about my book. It will be coming out next year, ideally, but if there's some delays, then make sure to follow me on Twitter so you can keep up with all the updates and potentially get cool perks.
Excellent. Yes. And on the description of this podcast, whether it's on YouTube or Buzzsprout or other places, I will definitely drop a link to Rudra's Twitter account where you can follow him. And then whenever the book's out, you can purchase it. I will be the first one to buy it, Rudra, 100%. It looks so cool because after The Martian, I believed that, when Andy Weir wrote it and then they made a movie out of it, I was feeling that there is a gap now. There is a hollowness amongst the sci-fi community, that nothing amazing like this has come up. So fantastic that you've written it, and we cannot wait to read it and to just go into that dream of sometime travel into outer space to Enceladus. Yep.
Just going to say that The Martian has been an inspiration for many, many, many people. And even
Yep.
scientists are agreeing that some of the major points and concerns which have been made in The Martian as to how exactly we'll be colonizing Mars have been taken into account. And they are saying that The Martian is a serious approach that could be taken by NASA and other space agencies when it comes to slowly colonizing Mars by first setting up small scientific colonies and then expanding it to include other forms of business such as private enterprise and stuff like that. It's interesting to see that despite many people's hopes that we'll be reaching Mars by 2030 or even 2040, and even Elon Musk is going as far as to say 2026, I personally don't think we'll be getting to Mars that soon. If anything, it will probably be like a competition between various private space agencies such as SpaceX, Blue Origin, even though Blue Origin's aim is not really to colonize Mars but to make space more accessible. And we'll slowly be seeing this growing competition between private enterprises that will eventually lead to this sort of innovation, similar to how there has been so much competition in the smartphone or tech industry that has led to so much technological developments over the past few decades. So that's what I think we'll be seeing over the next few years. And who knows, maybe we'll see something very similar to The Martian, but entirely run by private enterprises and private businesses.
Right, because that looks more feasible. Because with governmental organizations, they're always restrained by time, budget, and a lot of other stuff, while these startups like SpaceX and Blue Origin and others, they have such different visions for humanity. So yeah, I mean, can you also talk about terraforming? Because not now, but maybe in the distant future, we will definitely be terraforming, and without which we will not be able to sort of colonize the planets. What is your view on how practical that can be and how it can be done, by us?
Yeah. I guess I'll start off by saying this. Terraforming Mars is not going to be easy. So many people, when they think of
Mm,
terraforming, they think of terraforming Mars because that's the most likely place we'll start off by colonizing. The first thing which we think of when we think of colonizing other planets is colonizing Mars. And the next most logical step is to then terraform Mars such that we can actually stand on the surface without having to wear bulky spacesuits and whatever. I don't think we'll be
mm,
terraforming Mars in any way such that we can actually stand on the surface of Mars. And that's just due to the fact that if you look at if you analyze the planet Mars itself, you find that Mars has got no magnetic field, which protects the atmosphere. That's why Mars has got such a thin atmosphere compared to Earth's. Secondly, I don't think we'll be changing the surface gravity of Mars anytime soon. The surface gravity of any
mm,
planet is really a key as to if we should colonize that planet or not. Now, the thing with Mars is that Mars has got a very tiny gravity compared to Earth, and we don't know what the effects
mm,
of that would be on humans, but most likely our hypothesis states that most likely what will happen is that there will be some form of accelerated bone loss due to low surface gravities, and that's just something we cannot change. We have to add in these extra procedures and processes such as daily exercising for 2 hours straight and stuff like that to be able to maintain our body levels. And that's not really survivable until and that I wouldn't consider terraforming because terraforming means to make a planet more habitable and making it easier to live on that planet. And changing the surface gravity of Mars is also considered terraforming. We can partially terraform Mars, but not fully terraform, in my opinion. Whereas with other planets such
right.
as Venus, their surface gravity is very similar to Earth, so we don't have to change much about that. We only have to change the composition of its atmosphere. We only have to change a couple of tiny factors, maybe cooling down Venus such that it's more habitable, and then we can fully terraform Venus. It really depends on the initial conditions of the planet or moon which we're colonizing to see if it can be terraformed to our own personal needs. That being said, it's not impossible. It's just improbable within the next 100 years. Maybe in the
Right.
100 to 200 year mark, we might be able to start terraforming Venus, but terraforming Mars is going to be at least 1,000 years away because terraforming Mars is going to be such a difficult job that it would require us mining entire planets or entire uh, clusters of asteroids, and even going far as the Kuiper Belt, which is the furthest asteroid belt from the solar system, and mining stuff from there, such that we can extract the necessary resources and elements to then be able to, monitor the atmosphere, uh, modify the atmosphere, and potentially even modify the soil such that we can actually grow plants on Martian soil. It's going to be a very
Mm,
difficult job to colonize Mars. Terraform Mars. Colonizing Mars is going to be
right.
relatively easy because we are so determined to do that. In my
Right.
personal opinion, we should be colonizing Venus. Venus. We should be prioritizing Venus over Mars. Sure, if we get to Mars before Venus, that's totally fine. But again, we need to prioritize. We should probably be prioritizing Venus because it's a more habitable planet to be living on. Plus, there's not actually that many big issues on Venus that can't be dealt with compared to Mars.
Mm,
With Mars, you've got surface gravity, you've got the constant exposure of solar radiation, especially UV radiation, which can increase the likelihood of skin cancer. Whereas with Venus, the only thing that you need to make sure of is that you monitor how much sulfuric acid is contacting human skin, and Another thing is making sure that the temperature is manageable and the atmospheric pressure is also manageable. And all of that has been sorted out through independent research, and even NASA's considering the option of using cloud cities, entire cities floating in the clouds of Venus to as a way to colonize Venus. And I think that's a while it does sound crazy and kind of over the top, it's a better option in terms of habitability than, say, Mars. Yeah.
Mhm, mhm. Yes, that's a great point. Because for Venus, I think the the point that they were saying that it's not possible to terraform or colonize it is why touch a chemical boiling planet. I mean, it's like you said, sulfuric acid. It's so much rich in that, and it's also so much hot that unless it can be cooled down and or you make cities on the in the clouds, um, it's not going to be possible to stay. But on the other side, Martian is perfectly okay to touch down. The only problem is it has less gravity, and then very less, I think, also magnetism on its surface compared to Venus and other planets. So I think, yeah, both have their pros and cons. But you're right. I mean, I don't know why SpaceX and NASA has so much gotten into Mars. I'm pretty sure they have a strong case behind it as to why they are pursuing Mars first. But I think you're right. Pursuing Venus and then thinking about it at the same time is also going to be good for us.
Yeah. One point which I'd like to make is that with
Sure.
the strong case made by NASA and SpaceX to colonize Mars, I think there's a strong case which they have made, but that strong case is becoming less and less of a strength of Mars. The only strength which Mars
Right.
has is that Mars has water in the form of ice at its poles,
Mm.
and Venus unfortunately does not. But that's only a short-term strength. Mars has got a lot of short-term
Right.
strengths, but a lot of long-term weaknesses. And in terms of setting up a colony, long-term weaknesses outweigh the short-term strengths.
Mm.
Whereas with Venus, there are
Right.
some short-term weaknesses, such as the temperature and the atmospheric pressure of Venus, and potentially the problem of sulfuric acid. However, there are also some long-term benefits, such as the reduced amount of radiation, the um, the more solar energy that is cast on Venus compared to Mars. So there's more solar energy, which means more electricity if you were to set up solar panels. Also, Venus has more gravity than Mars, and from what we know, very similar. If a planet has very similar gravity to Earth, then there's very little chance that our bodily functions or our physical bone structures will change that much in that planetary environment. On Mars, what will happen is that we will need to constantly exercise. We would constantly need to maintain our physical levels in order to make sure that we don't lose, to make sure that we can sort of mit, reduce the amount of bone loss that we have over time. That's why I think Venus will be a long-term colony compared to Mars. Mars has got a lot of problems in its way, but if NASA and SpaceX still want to colonize Mars, they can. And this idea and this bias towards going for planets that have water, it's a reasonable bias to make. But there's also just another
Right.
bias which many people are considering, and that is just that we like to land on stuff. So we'd like to touch the ground. We like to actually live on land rather than, floating in a cloud city on Venus. And this additional bias also makes people want to still prefer Mars over Venus, even if Venus is a more habitable option compared to Mars. Uh, there's a lot of factors here and there, and there, as you mentioned, there are definitely pros and cons to each of the individual planets. But in my personal opinion, as a person who has studied these two planets through online resources, I think it
Mm.
makes a lot more sense to colonize Venus, even if it means having to deal with some pretty strong short-term weaknesses.
Right, right. Great answer. I mean, just very quickly, if you can also talk about, there was an idea about terraforming these different planets, and Enceladus and Europa looks much more favorable in that condition because they host a lot of ice. So, converting that ice into water by actually bombing those planets. Something like Elon Musk said it for Mars, which is like, if you really want to transform it, and it doesn't it look so logical, because what it's going to do is probably shake up the planet, but it's still not going to impact Earth or Earth's or anything related to Earth. So why not just bomb them and then see if they change their atmosphere, cool down less a little bit, like in terms of Venus, and then in terms of Enceladus, melt those ice and convert them into water, so that probably life can originate. So what's your view on that?
Well, firstly, I think with the whole Elon Musk comment of nuking Mars, which is what he said, just throw a thermonuclear bomb at Mars. Well, firstly, that's a pretty hot, controversial argument, pun not intended. But I
Right.
personally think with the thermonuclear bomb idea, I don't think that's going to work. Yes, it might melt ice. It might melt the ice on Mars, but at the same time, you're also going to contaminate the ice with radioactive material, and that's not going to be
Mm,
good if you're trying to provide water to potentially thousands, if not millions, of people who are going to be in a Martian colony on Mars, potentially living close to the Martian pole so that they can get lots of water. Secondly, since Mars doesn't have an atmosphere and it doesn't have a magnetic field to protect itself, as well as, say, with Earth, actually Mars does have an atmosphere, but it's not that it's it's barely anything compared to Earth's. Since it does not have any of those two things in a necessary amount to protect people on the surface of Mars, what happens is that whenever you melt ice on Mars, it doesn't actually it melts the ice, but then it also instantly sublimates into gas. So the ice converts
mm,
directly from ice to gas, and there's only and it doesn't actually get converted to water. You need a certain atmospheric pressure and other factors in order for it to stay in in liquid form. By nuking Mars, what you're essentially doing is you're transferring all of the energy from the bomb to the ice. The ice is going to melt, but then it's not actually going to melt into water. It's just going to sublimate straight into gas, and then all of that gas goes into the atmosphere, and due to the sun's solar radiation and Mars's lack of a magnetic field, all that gas and that atmosphere will slowly be dragged away from Mars's gravity until it's basically not even a part of Mars anymore. That's how we think Mars lost its atmosphere, due to this excessive amount of solar
mm,
radiation over billions of years. So
mm.
that means that if we drop nukes on Mars, eventually what's going to happen is that we're actually going to be left with less water than we started. And that's actually going to be a problem for people trying to live on Mars. I think
Right.
there are some other scientific reasons, and I believe there are some people who've made videos about this on YouTube. I'm just going to say this. I think it's a pretty dumb idea. And I think even Elon Musk might have, and I'm not exactly entirely sure, he might have uh, fell back on his arguments of nuking Mars. I think he said that he was just joking, and that was just it was just a joke.
Right.
However, we
Right.
do need
Right.
to warm up those planets. We do need to warm up the ice. Otherwise, I mean, how are humans going to survive? And one way you can do that is through energy. So if you get, say, solar energy, you can then transfer that and concentrate that into heat energy, which can be used as a constant source of energy transfer. And that energy transfer will melt the ice in a controlled fashion and will allow us to drink that water. Same thing goes for Europa and Enceladus. They're so cold. That's why they're ice and not some water bubble thing just floating around Jupiter or Saturn. It's because they are so cold. They are, I think, negative 150 degrees Celsius or something like that.
Mm,
And because
right.
of that, we need some constant source of energy in order to be able to melt it. Now, on Europa or Enceladus, you can get one way which I was personally thinking of, and this sort of revolves back around to my book. One way which I was thinking we
Mm,
could harness that energy is through the tidal effects of Saturn on Enceladus. This causes, the moon itself to squish and squeeze and in these weird motions, and basically that melts the interior of the planet. So that's why scientists believe that there's a giant ocean underneath Enceladus, but a thick layer of ice on top. It's because all that ice underneath that sheet of ice, underneath the surface, is melted by Saturn's tidal effects on Enceladus. If we could harness that
mm,
energy through, say, geothermal means or something like that, then we can use that as a source of energy for our electricity needs. It could be it could be used as a way to melt further ice if we need to. But yeah, it's a difficult question to answer. I think nuking Mars is going to be a terrible option, but we need a way to warm up those planets and to be able to make the planet more habitable. And this is kind of terraforming. It's a very basic form of terraforming. Many people think of terraforming as just like, waving a magic wand at a planet and being like, "Woohoo! We made it more habitable. Wow, green forests on Mars." It's not that. It's a process that takes thousands of years. And if you know a famous organization on YouTube called Kurzgesagt, they've done two separate videos, one on terraforming Mars and another on terraforming Venus. And in both of them, they say that it's going to take centuries, if not millennia, uh, to be able to terraform those planets in a reasonable fashion or in an optimistic fashion.
Yes, great point. So it's good to stay sane and not go insane about nuking the planets. And Rudra has given the reasons behind it. So fantastic, Rudra. Um, so let me ask you something connected to that. Is it's good that we are thinking about these planets and moons, but how do we reach there is the most important point. So how difficult do you think it is for humans to travel uh, to our nearby planets like Mars and others? Um, Basically, will we ever be able to travel outside our cocoon like atmosphere and venture out into interstellar space? The reason why I asked is you talked about losing bone density and other things, radiation. How would we mitigate them, and how will it be possible for us to still travel and venture out into the far-flung places of the universe?
Yeah, for sure. I think we're already on the verge of being able to do at least interplanetary travel, or at least we are at this stage where we can start to think about in more realistic terms about how we colonized the solar system back in, say, the 1970s or the 1980s, when there was still hype around us going to the moon. Many people were like, "Oh, we just have to do the same thing, make a bigger rocket, and then we get to Mars." The thing is that it's not that simple, because the thing is that there's various different factors that need to be taken into account in order for a mission to, one, be successful, but also to be very efficient in terms of costs. for example, we have been talking a lot about colonizing Mars and colonizing moons around Saturn and Jupiter. The thing is that for most of the time, except for a brief window every couple of years, most of these planets are really far away from Earth, and
Mm.
getting stuff to those planets is a very difficult job and requires lots and lots of money. That's why NASA spends like hundreds of billions of dollars on projects, and all they send is like a tiny probe. But the reason why is
Right.
because most of those costs actually go into making the fuel. And once you make the fuel, fuel and you put it in the rocket, then then there has to be enough fuel such that one, the rocket is able to get outside Earth's sphere of gravitational influence, but two, you also have to make sure that the rocket's not heavy enough such that it just sort of just stays there and just stays there on launch and it doesn't go anywhere. So there's a lot of factors
Mm.
that need to be taken into account. I think what we will see is we'll see the implementation of new technologies in space travel. So we've been seeing a lot of we've been seeing more efficient fuels. Specifically, I think SpaceX is using some of the most efficient fuel out there in their rockets. Then
Mm.
there's also the possibility of using fusion power, whether that be pulsed fusion power, so it pulses once every couple of minutes or whatever, or however much time you need in between each pulse, or constant fusion power, which means fusion power that's essentially constantly pushing the rocket forward. Now, when you're in space, many people think that, oh, you need to constantly have some sort of fuel going, otherwise the rocket will just stop. But according to physics, that's not really the case. If there's as long as you're not in some gravitational sphere of influence, or there's not another force being exerted on an object, as long as there's no friction or whatever or other forces, there the object will still keep moving at a constant speed or constant velocity. And this is outlined in Newton's first law, if you recall back to your year 10 physics class. And that is just that an
Yeah.
object in motion tends to stay in motion, and an object in rest tends to stay at rest unless an external force is being applied, or a net force is being
Mm.
applied. And the same thing applies with rockets in deep space. There's no gravitational force, there's no air resistance, there's none of those stupid pesky forces. And so what you're left with is you're left with a rocket that does not need any fuel actually in order to get to its destination. However, the problem arises with one, getting the rocket into space in the first place, and then two, slowing down the rocket such that it actually lands in a orderly fashion on the planet of designation. Otherwise, you would end up with a crash. Otherwise, you would end up with a rocket that's in bits. And spoiler alert: this is what happens in my book, Hacking
Right.
Enceladus. Yeah, I
Right.
think what we will be seeing is over the next few decades, we'll be seeing, as I mentioned, more technologies. But also, what we'll start to see is we'll start to see our ideas or our plans of colonizing, say, Mars being implemented in much more smaller colonization projects, such as colonizing the moon. Now, sad thing is that the plan for colonizing the moon has been delayed by a year by NASA due to a lack of funding, which is just sad. But
Mm.
it's going to be an opportunity to see whether our plans of colonizing Mars will really work in a much more smaller setting in, say, colonizing the moon, because it only takes 3 days or less than 3 days to get to the moon nowadays with modern rockets, and getting to Mars might will only will take a couple of months. And so we need to be able to analyze in great depth and in great detail how space travel affects humans. We don't really know what happens. We don't really know what happens to humans in space, besides the fact that yes, there's an increased amount of solar radiation. Yes, it has certain effects on certain bacteria, our certain cells in our body, certain viruses. Most viruses are actually enhanced when they're in space. We need to
Mm,
be researching more about this, and that's why we have the ISS to be able to research zero gravity uh, scenarios and prepare ourselves for interplanetary travel. In terms of interstellar travel is going to take a couple of decades longer. Maybe by the end of the century, we might have sent a unmanned probe to the nearest star, but a manned mission will not be conducted in the next 100 years, because by that point we will still be trying to colonize the rest of the solar system, and then trying to use all the resources on those planets and in those asteroids to the best of our capabilities, and just trying to improve our technology even further and advance to become a type 2 civilization. That's what we want to do in the next few decades. We shouldn't be thinking too much about interstellar travel before we have even done our first interplanetary travel. So, yeah.
right. Great answer about space travel. Thank you, Rudra. Um, yeah. So, what do you think? Why are we created in this universe in the first place? Is it just an accident of life that we are here? That a conscious life can be born on this planet? Or do you think, like we have discussed in our last episode, if you remember, about panspermia, happened to our planet? So, what, according to you, is more practical, which is more acceptable, logically?
So I'm going to be talking about this through a more scientific perspective. This is
Sure.
very,
Yeah.
to be honest, this idea of panspermia, it's sort of an outspoken theory, and to be honest, it kind of reminds me of our perception of the lab leak theory in coronavirus research, or the origins of
Mhm.
coronavirus. Where did coronavirus come from? Most people think it came from bats or whatever, wherever it came from.
Right.
I'm not really a bio person, but there's been a lot going around recently stating that, oh, maybe it was a lab leak, but I'm not going to propose anything. I'm just saying this reminds me of that. Scientifically speaking, we we believe we believe most of the indirect evidence so far seems to point towards the fact that life was created here on Earth and not through space. However, the idea of panspermia has not been ruled out. It's just that there's
Mm.
a lack of direct evidence towards to support the panspermia theory, and the same thing goes for the uh, uh, on on Earth theory, is what I'd like to say. So there's no direct evidence that says life was created on Earth, but there's no direct evidence that says panspermia is also true either. Now, in terms of how life came about, I'm not really an origins of life researcher, so I can't really comment
Mm.
on anything with full certainty. But what I will say is that what we believe is that life didn't really come out of an accident, but it wasn't really entirely planned either. It wasn't like some god came down and put the molecules together and said, "Hey, presto, that's life." Um, it's more of a it's more of an organized sequence of events that just so happened to happen at the right time, at the right place, that produced life. Is it an accident? Maybe. I'm not exactly sure. What we believe is that life was created through organic molecules deep in the ocean, where they were dissolved in water. Why water? Because water is a really good substance at dissolving various things. You can think of it like, water can dissolve pretty much more substances than any other liquid. And so it's a great place for various different types of chemistry to occur. Specifically, life might have arose near hydrothermal vents in the oceans, because hydrothermal vents provide energy in the form of heat, and water provides a way for molecules to join together in a solvent and then react to produce the necessary organic molecules, and then eventually all the biological molecules that we see, enzymes, lipids, carbohydrates, all these necessary building blocks that produce life. In scientific experiments, we have successfully been able to recreate some of these different situations through applying a little bit of energy, concentrated energy in water with some molecules dissolved in it, and then we found that afterwards a reaction had occurred that allowed us to produce some form of very simple biological molecule. After that, once we got self-replicating biological molecules, then they started to evolve and get more complex. The first cell on Earth, the first form of cellular life on Earth might actually be very different to the form of cellular life we have today, because cellular life today is incredibly complex, and that is due to roughly 4 billion years worth of evolution which occurred here on Earth. Now, that's not to say that panspermia is wrong or panspermia is a conspiracy theory. It's certainly a theory that has taken some consideration. We believe the reason why we believe panspermia might be a theory that could explain abiogenesis, the process that converted not life to life, is because life first emerged on Earth roughly 4 billion years ago, and around that time there was a bombardment of asteroids and comets and other small rocks on Earth, and this was referred to as the late heavy bombardment. And some of these asteroids might have had organic molecules, and these organic molecules might have been dispersed around the world, and then they might have come together in water and then reacted to form abiogenesis. However, other people this is not really the true theory of panspermia. What I'm referring to here is that asteroids provided the organic molecules, which then turned into life. Panspermia really says that life itself came from asteroids, and that that seems unlikely because we haven't found any direct evidence of or indirect evidence of life on any other planet. So the fact that panspermia occurred roughly 4 billion years ago through interplanetary asteroids doesn't seem to make sense. However, if panspermia does turn out to be true, and we find that there is life on other planets and potentially even exoplanets, and this could suggest that life is more abundant than we think it is. And if life is more abundant than we think it is, then we might not be as special as we think we are. And if we truly are the only advanced form of civilization in the entire galaxy, or at least in our part of the galaxy, then we could be like, to other future advanced civilizations, we might be perceived as gods. And one goal which we could take as an advanced civilization is, if we do find other less advanced civilizations, then it should be our duty to then be able to help that civilization out and put them on the right path, such that they don't annihilate themselves or they don't destroy themselves or nuke themselves out of existence. That's something which we might be very close to doing, but it's something that needs to be taught to other less advanced civilizations if we do find them.
Great answer. And when you were talking about life coming from possibly other places, with the theory of panspermia, asteroid hitting us that was carrying some organic life, and then it started here. I was also thinking about then the Fermi's paradox, which means, if that would have been the case, then where are all the people, or where are all the colonies, or where are all the civilizations? Because if this can happen here, it can happen at other places in the universe as well, wherever there is a Goldilocks zone, wherever there is possibility of life starting. So can you talk about what is your view of, we are not the only one, or probably it is just a matter of chance or probability, a high probability that we are the only one in the universe, a life form?
Yeah, for sure. So for those who don't know, the Fermi's paradox basically questions why we appear to be the only advanced civilization in
Yeah.
the universe, or in the galaxy, to be more specific. And the reason why that might be the case is because simple life might exist everywhere, but advanced civilizations might not exist everywhere. Another possibility is
Mm,
that we have somehow surpassed some form of great filter, which other civilizations have not been able to, and have
not.
basically extinguished themselves out of existence. So they basically destroyed themselves out of existence. Now, in terms of uh, what panspermia would mean for the Fermi's paradox, if panspermia does turn out to be true, then that sort of resolves the Fermi paradox, and it sort of states that there is life in the galaxy, and and if we do find life on other planets, and we can somehow make the connection that that planet sent its life through an asteroid to us, then it can sort of set the stage for really determining how many civilizations we expect to see in the galaxy, because we don't actually have much data about this. Remember, we are the only advanced civilization that we know of in the entire galaxy. So how are you supposed to do statistics with a sample size of one? It's just
Mm,
impossible. And so determining how many civilizations there would be through something like the Drake equation is just not going to be possible until we actually find life. And that's just a matter of probability and sheer luck. Now you mentioned the Goldilocks zone, which is,
mm,
I believe it's a guide to where we can potentially find civilizations, but it definitely doesn't suggest that if a planet is within a Goldilocks zone, then it must be a contender for life. Because the thing is that there's also a
mm,
bunch of other factors that contribute to if a planet is habitable or not. For Earth, we live in the Goldilocks zone, but so does Venus. Venus also is just within the
mm,
Goldilocks zone, and so is Mars. Why don't they have life? And the reason why is because Venus has tons of CO2 in its atmosphere. Mars is just a little too far away and it's really small. Whereas with
mm,
And the same thing applies with exoplanets. We need to find planets that have a magnetic field, are not too hot, not too cold, have the right temperatures such that water can exist in all three of its forms. Well, not really all three of its forms, but most of its forms, especially liquid. If we find liquid water, that's a golden sign that life might have existed on that planet, because, as I mentioned, water is great at dissolving things, especially liquid water.
mm,
And if we find water on another planet, then that sort of indicates that yes, we might there might have been some form of organic chemistry that might have been occurring on this planet, and that organic chemistry could have led to life. There are probabilities which we still need to figure out, but we will be figuring those out in the next couple of years, or maybe even the next decade.
What do you think, Rudra? Are we alone in this universe? Let us discuss the possibility of more habitable planets, like like you talked about exoplanets and others. I mean, we have been doing research for the last, I think, 15, 20 years with very, very high precision telescopes. And yes, we could identify a lot of exoplanets. So there is a possibility of life there. But we haven't still be able to find out whether there could be a life form there. So what, according to you, could be the possibility that it is for sure the fact that we are either alone or we are not. The reason why I'm saying this is, and I'm sorry I'm taking a long time describing it, is that we haven't actually reached out to galaxies and then their star systems and their exoplanets, which are perhaps, like, let's say, 100 or 500 light years or million light years from us. So, I mean, of course, science is progressing. We are doing research every day, trying to identify and find out more such planets and try to understand the complexities of how life can emerge. But what, according to you, is the possibility that we are either alone or we are not?
Well, I guess let's start off with the extragalactic stuff which you mentioned. We just our
Right.
instruments are just not sensitive enough to be able to detect exoplanets around other galaxies, let alone other planets around or on the opposite side of our galaxy, because planets are just so small compared to stars or compared to bigger objects like nebula. They're just so tiny. If you were to, for example, look at Earth, try and find Earth from, say, 50 light years away on another planet, it would be barely distinguishable. Because the thing is that pla finding planets is just very hard, and you also have to be very
Right.
lucky if you do find planets. And the way we find planets is through the transit method. That's I won't talk
Hmm.
too much about it because I know we want to get back to
Yeah.
um the topic of the Fermi's paradox and potentially finding life.
Right.
Now the thing which many scientists would like to see on in exoplanets or even in planets in our solar system is looking at biosignatures or biological signatures. And I'll give you an example of what biological signals, like how big of an impact they have in the scientific community. Um, if you recall, a group of scientists published a research paper claiming that they have found more phosphine in Venus than they previously expected, and that could be
Hmm.
due to biological processes. They weren't exactly sure, they still had to confirm, they still had to double check through independent researchers, but it sent shockwaves throughout the community. Because the thing is that the possibility that life could exist on a hostile planet like Venus
Hmm.
would just be game changing, because then that would open up so many
Right.
more possibilities for where life might exist. Life doesn't have to exist on a uh, perfectly uh, warm planet like Earth, or which is not too hot but also not too cold. It could exist on extreme planets such as Venus or Mars, or even as far as Neptune's moons. But there was some revelations, and this group of scientists eventually had to state that their research was inaccurate, and that there was actually a miscalculation in their data, and that there was actually just as much phosphine as they expected on Venus. But you could see the impact it had. Now, if we were to actually find an actual biosignature on an exoplanet, then that would be big news, because yes, it's still indirect. Yes, it's still some form of indirect evidence, maybe borderline direct evidence, but it would still be a big thing, because then that could be used as sort of the smoking gun for us finding life. That's what we want to look for, biological signatures. However, if we were to actually land on those planets, for example, we have rovers on Mars right now, they are collecting samples. If we are able to be able to collect those samples and then look at them in specially monitored and sterilized laboratories, then we can further analyze through human methods whether life exists in those samples. We have to be a bit lucky though with those samples, because we're only collecting a few grams out of potentially an entire planet's worth of surface. And you know, finding life in that sample might be extremely unlikely, especially if most of those single-celled life which we're looking for have already disintegrated, which is a possibility, which I'm not really sure about because I focus more on radio astronomy and pulsars and neutron stars, which we talked about in round one. Yeah, hopefully there's a link below for that. That would be really cool.
Yes. Mm.
Uh, yeah, that's pretty much all that I have to say about biosignatures.
Okay.
There's new fields opening up to look at how we could potentially, find new ways of determining if life exists on other planets by analyzing some of the biological
Mm.
signatures we find here on Earth. So that might be through
Mm.
fossil records, or that might be through atmospheric analysis and other stuff like that. And that would be really interesting to see.
Right, right. Fantastic. Great point. I was also thinking if you can talk about the fact that, and I discussed this with Lawrence Cross as well when he came to the podcast, is that the our existence on the cosmic scale is such minuscule when you compare it to the whole lifeline of universe or its age, which is about 13.8 billion years, that there could be life on Mars, perhaps even advanced one, and then it's wiped out in the last 2 to 3 billion years ago, and then perhaps because of that reason life would have wiped out from there because it has become inhabitable. Like perhaps if we don't care about climate crisis right now on Earth, our planet can become inhabitable. So I mean, the point I'm trying to get onto is that what in your view is the fact that we cannot just judge life based on what is present today, as of what we see today or what we can research today or what we can identify today, but life can actually exist in different time scales, and perhaps that's how it is. So yeah, if you can talk about it.
Yeah, for sure. I mean, if you look at the Fermi's paradox, there are various resolutions to the paradox, and as you mentioned, one of the resolutions is the fact that advanced civilizations, they become so advanced and they develop such advanced technologies that those advanced technologies eventually destroy themselves, and
Mm.
these might be pathogens, artificial gain of function research, which is some of the research which we're doing right now on viruses, which are making them more deadly. That could be a uh,
Mm.
potential technology or research that could end humanity as we know it. Another another option is just the fact that we've got so many tensions between different groups of people, such as there's
Right.
religious tensions, there's economic, there's geopolitical tensions that might result in
Mm.
a war that wipes all of humanity. I mean, there was even a point in history which we refer to as the Toba super eruption that almost
Mm.
wiped out all of humanity. There were only about 1,000 people who survived that Toba super eruption,
Right.
at least on that island or in that region. And so
Mm.
what this shows is that it could be the fact that, like, we might be existing right now, and then there was another advanced civilization that existed before us 3 billion years ago, but then they died out for some unknown reason. It might be that, after we maybe if we extinguish ourselves or kill ourselves or destroy ourselves, there might be another advanced civilization that just might pop up and think, well, we're the only ones that exist in the universe right now. This is so odd. It's a possibility. And on the point that you mentioned that we as a civilization are very minuscule compared to the universe, yes, we are totally,
Mm.
physically speaking, we are very minuscule. However, we also have to reconsider the fact that we are the only observers of the universe. I mean, who is going to take
Right.
in the entire beauty and, uh, you know, the entire beauty of the cosmos. There's without us, there's not going to be anyone to look at the universe and just be like, wow, man, I live in this universe. It's so cool. This is one of the philosophical things which I always come back to, and that is that, I mean, if you want to feel grateful for something but you don't have anything to feel grateful for, just feel grateful for the fact that you might be a part of the only advanced civilization that can look up at the stars and be like, man, I live in this universe. It's so cool, right? And that's something to
Right.
feel really unique about. And you know, it's and if we aren't the only advanced civilization in the universe, so be it. We need to be able to cooperate with those other advanced civilizations, because otherwise that could result in total annihilation of both advanced civilizations. But that's in physical space. Physically, in space, we are minuscule. Mentally, we are not minuscule. We are actually we could actually be the most advanced civilization in the entire universe right now. In terms of
Right.
time, or, in terms of time, we might actually not be as minuscule as we think. Yes, life has been around here for 4 billion years, and that's actually a very small period in the universe's history so far, only about a third of the universe's history so far. But, remember that the universe has still got billions, if not trillions of years left before the last star dies. And if you look at the time period between the start of the universe and when the last star dies, you find that we are actually at the very start of this period, or this epoch of life, as I like to call it. And you know, if we don't find life in our galaxy or in our solar system, so be it, because what that shows us is that we are potentially the first advanced civilization, and that there are many more other civilizations to come in the future, and we might be one of those guiding peoples that will sort of look down at newer civilizations later down the line and provide guidance and help them out in achieving, what they want to achieve.
Thank you, Rudra, for this round of the episode. Really enjoyed what you talked about, and I'm pretty sure, like me, thousands and millions of people who would listen it to whenever would definitely benefit from it. Before we wrap up, let me also share that pretty soon we will do a round 3 with Rudra on some other topics related to artificial intelligence and climate crisis. So stay tuned for that. Thank you, Rudra. Do you have anything to say before we wrap up?
Oh, no, I'd just like to say thank you so much, Vivek. It's been a pleasure to join your podcast. And can't wait to see how round 3 turns out.
Right. Fantastic. Sure. Thank you so much, Rudra. We'll connect with you again then.
Yeah, thanks, Vivek.
Thank you. Bye-bye.
Thank you for listening to this podcast. Please support this podcast by liking, commenting, sharing it with your friends, and also subscribing to this channel. Thank you, and we'll see you next time.